Hello, virtual GED students. Today we're going to continue our exploration of the subject of data analysis, talking about some multi-step percentage problems or percent problems. So one of the problem types listed on the math study guide for the GED is that they might have multi-step percent ratio or proportion problems. So we're hitting that with the topic of percents today. When those do come up on the GED, they tend to be in the form of word problems, often with accompanying tables or diagrams, which means you'd get a calculator. So we will be using our calculator as we do this. Also be aware that percentages are a part of the concept of data analysis, meaning they could also show up on the science or social studies test, which you're also allowed to have a calculator on. Just a real quick review, since it's been 2 weeks since we've done this, and this is the main skill we need for this. Let's see if we remember how to find the percent of a number. Let's just imagine we had something like 17% of 40. So if we were told to find 17% of 40, so what we learned last week was that we didn't usually do math with a percent sign, especially if we were going to do this by hand. We wouldn't use a percent sign. We would use one of two possible equivalent forms. We could turn any percent into a decimal or a fraction. Now, a lot of students tell me, well, I can't remember how to turn it into a decimal or a fraction. You don't have to remember if you know what percent means. So percent literally means divide, per means divide, by 100. Cent means 100. So if I'm talking 17% of 40, there's two ways I could write that. I could use the fraction bar for a divide by sign, 17 divided by 100. Or if I don't like doing math with fractions, I could do the division. And if I were to do that like in my calculator, 17 divided by 100, I would find out that that was 0.17. Or basically the number 17 with two less decimal places worth of value. I just move a decimal 2 places to the left, and I've divided by 100. And so we could go with either way. Now, because I have a calculator, it's easier to use decimals. I'm going to do 0.17. Now, we said, well, of literally means multiply. And students forget that because they forget that multiplication can make things smaller or bigger. Okay, but of does mean multiply. So I'm going to multiply 0.17 by 40. And that is one way of doing 17% of 40. Okay, so I could type that into my calculator, my TI, 0.17 times 40, and I would get 6.8. But just because I like you, Maricela, I want to show you something.
Okay.
Your calculator actually has a percent button. So as long as you know that of means multiply, you could actually type this expression exactly the way you see it into your TI. You didn't even have to change it into a decimal or a fraction. You could have just literally typed 17%. So here's how you do it. You would type 17. Now the percent sign is in green up above the parentheses button. So you see a parentheses button?
Yes.
And it's in green above that. Anytime you want something in green, you have to press the second key. So I'm going to press second and then that parentheses button to get my percent sign. And you can see now I have 17% in my calculator. And then I could just times that. I could do of 40. And I get 17% of 40 is 6.8. So whether you use a decimal form, a fraction form, or you use your TI to do it in percent form, you'll get the same answer. Does that make sense?
What I'm doing wrong because I put 17%.
I bet you did the convert to a percent button instead of the regular percent button. I'm actually glad you're having that problem because other people on the internet would. Notice above the right close parentheses, there's a convert to percent button. That's not the one I want. That one takes an answer you already have in a calculator and turns it into a percent. I don't want that. I just want the percent symbol, which is on the open parentheses button above that one. Yeah, we could use that close parentheses, that convert to a percent button. Let me show you an example. 3 out of 4 virtual GED students fell asleep in Kate's class. I don't know how you guys do it because I scream so much, but somebody always still manages. So what percent of students? So this is just a straight conversion problem. They're asking me to take a fraction, the 3/4 of VG students who fall asleep in class, and convert it into a percent. Does that make sense?
Yes.
Yep. Okay, so I could start by typing in the 3/4 into my calculator with the N over D button. I would type N over D. I would put the 3 in on top of the fraction, the 4 in on the bottom, arrowing around. And then that's when I would use that convert to a percent button. I want to take 3/4 and change it into a percent. That's what that button means. And you would find out, of course, 3/4 is 75%. So there's actually a lot of instances in math where a percent is only one of the things you do. Multi-step percent problems happen all the time, okay? Some really common times they happen is out when we're shopping. It's with money. So here's some times. Tax, tip. Taxes are based on percents. Tips are based on percents. Markups, discounts, and commission. Now, these are not the only kinds of multi-step percent problems, but these are some of the most common. They show up all the time, okay? Let's think about the first one, tax. When you go to the store, they ring up your order, how much it's going to cost. For example, it could be like $5.72, and then they do something. They add on a tax, and the tax is percentage based. And so what you have here is you end up with a two-step problem. You have to find out what the tax is, and then you have to add that on to the original amount. Okay, so let's try an example down here. Dawn, every time I have the ladies on, we always start buying pairs of shoes. Dawn bought a pair of shoes for $22.50. If there is an 11.2% sales tax, what will she pay for the shoes? And I'll just clarify that I do mean after tax. So you and I know that whatever is the marked price is not what we're really going to pay. We're also going to pay tax.
Yeah.
Okay. So now students do this one way and mathematicians do it another way. It's not that we're doing different math. We're doing the same math. Okay. We're just writing about it differently. Mm-hmm. So what most students do is they do this as a two-step procedure. What I see students do is they first find tax. They say, okay, the tax is going to be 11.2%, but 11.2% of what? Percents are always of something. A percent is a portion of something. So 11.2% of what? Of the $22.50. You're going to pay that much in tax. And that's really easy to do in our TI, especially now that we know about the percent button and we're so lazy. I could literally type 11.2%. And we said of means what? Of means multiply. So I'm going to do 11.2%. I typed percent in my calculator times 22.5 or 22.50. And then I find out that my tax is $2.52. But this problem is not done yet because they didn't ask me to find what is the tax. They asked me to find what will she pay for the shoes after tax. So now I need to take this tax and do what with it?
Add it.
Exactly. So now I have to take my original $22.50 bill and add on my sales tax of $2.52. And I can do that in my calculator. And I get 25.02. Now, this is the way most GED students think about this problem. And this is a legit way. There's nothing wrong with it, okay? But I need to show you another way because the GED has this trick where the answers, instead of being single numbers, are expressions. So I don't want you to lose your mind if somebody writes about this differently than you think about it. Okay, so I want to talk about how a mathematician would do a problem like this. What we usually do is we talk about all our steps right from the beginning because we know the order of operations. And this is what a mathematician will say. They'll say, well, to find the cost of the shoes or the cost of the shoes after tax, I would take the cost of the shoes, $22.50, and I would add on 11.2% of the cost of the shoes, $22.50. Now I'm talking about doing the exact same work that you are. I'm just writing about everything I'm doing all at once instead of breaking it into two separate steps. But can you see how I have the $22.50 and I have the tax on the $22.50? Mm-hmm. And what throws students is that they go, oh my gosh, I used the $22.50 twice. Well, yeah, so did you in your work before. If you look on the left-hand side, first you found 11.2% of $22.50, and then you added that on to $22.50. So you used it twice too. You just didn't talk about everything you were going to do at the beginning. But can you look at the expression on the right? Does it make sense to you, Maricela?
Yes.
Okay, wonderful. And a mathematician would type this exactly into their calculator this way. And if you type it just like I did, we should get the exact same answer we got before, because good math always works. And I'll see that I get 2502. This is the way I'm going to be writing about things, because I need you to get familiar with the way it will most likely be written on the GED. Okay, so I'm going to pull up some examples now. I already told you there's tax, there's tip, there's markups, there's discounts, there's commission. There's lots of ways we're going to see multi-step percent problems. And I've got a whole list of examples so that you don't have to write all these out. So I have some multi-step examples here. It's all over the place, much like the GED will be. We're going to use our trusty GED calculator. You're going to notice that even though I've got all these different examples, they're all word problems. That's the style I would expect on the GED. Okay. So number one, it says Bernice would like to tip her server 18%. If the bill for food and drinks was $53.40, how much should she leave to cover the tab and the tip? Let's go straight to the question. Students really struggle with where am I going? So they asked me, how much should she leave to cover the tab and the tip? Now, because students are really, really bad at word problems, usually the thing that I ask students to do before they start a word problem is to paraphrase what we're looking for, to tell me in your own words what we're looking for. If I ask you how much should she leave to cover the tab and the tip, what am I looking for here? I want the total of the bill plus the tip. So let's make a plan for this. I want the total of the bill plus the tip. So let's start with the bill. How much is the bill, Maricela?
$53.40.
So we will plan to take $53.40 and we will plan to add on the tip. Now this is where it gets a little tricky. How much is the tip?
We have to find the 18% of 53 and 40.
Exactly. And 18% my calculator can handle, so I can write it just like that if I want to, or I could write 0.18. It's the same thing, okay? But 18%, and of means multiply, and we're 18% of, you told me 53.40, and I'm going to write about it all at once because that's the kind of girl I am. I'm too lazy to take two steps. Okay, and I can type this entire expression into my TI calculator. It can handle multi-steps even though it freaks students out a little bit. 53.40 plus 18% times 53.40. And if you wonder, why is this working? Don't we need to find percent first? It's working because the order of operations multiplies before it adds. The order of operations has already accounts for this. It will multiply before it will add. Your calculator follows the order of operations. And I get this, 63.012. Okay, that is what I got out of my calculator. Are you cool with me so far, Maricela?
Yeah. Mm-hmm.
Okay, but one thing I have to warn you of about word problems. Sometimes word problems will imply rounding when you don't even know about it. And here's a case like that. This is 63 what? What unit am I in right now? We're giving them 63 what at the restaurant?
63, oh, $6?
Yeah, exactly. This is $63. And dollars, just because they're a real life concept, have a limit. We have a limit of the number of decimal places we can have on money. And that's because our money system only goes so small, right? We have the smallest coin. Our smallest coin is what?
1 cent.
1 cent, exactly. A cent is 100th of a dollar. It's a dollar broken into 100 pieces. And so we are limited to the hundredths place with money. We can only go up to 2 decimal places. We can only go up to the cents place as we think about it. And so we are going to have to drop this 2. And rounding says that we should consider if that 2 is big enough to matter before we drop it. And of course it's not. We're not halfway through our digit system yet. So we will just call that $63.01.
We still have to give
left a very exact tip. What was that?
We still have to give the 1 cent to the.
You don't have to. You and I know in a restaurant we would probably just give $63. It's true. But if Bernice really wants to tip her server 18%, this is as close as she can get to 18%. Now, I got to tell you, girl, I never do exact math and multiply with decimals. You're not going to see me busting out a calculator when I'm in a restaurant. I use that 20% trick I taught you guys the other day, where I just move the decimal, double it, give them a little more money. I'd rather avoid decimal mathematics at all times. But the test will be asking you for exact answers, so you better know how to find an exact answer as well. Now, number 2 shouldn't stress us out so much now that we've been looking at it this way, because number 2 is usually one of those problems that really messes with students' heads. So let's look at number 2. It says Lilson's Fine Wine marks up wine 125%. If they are able to purchase a certain wine wholesale for $4.20, which expression below shows the sales price after markup? Okay, so we first need to know, to do this problem, what a markup is. So what is a markup? If you guys don't already know this, a markup is the amount that a store adds on before they sell it to you. So every store buys their things from somewhere, whether it's Safeway buying their milk from the dairy, or it's the wine store buying their milk from a winery. They're buying it from somewhere. They buy it at a cost. Okay, so then they add a markup, and usually it's percentage base of how much money they want to make off of that wine. This is the money their store makes. So really important that you understand that this is an additional, it's added on. Okay, so let's give this a try here then. So what we said was they start with a cost and then they add on a markup. So Maricela, what was the cost of our wine?
$4.20.
$4.20, thank you. And to that we want, and it's $4.20, let me not forget my decimal place. And to that we want to add on the markup. What did they tell us the markup is?
125%.
Yes, and be very careful. Everybody watching, be very, very careful. 125%, percents are always out of something. So when you ask, you don't just add on 125%. You can't do that. We need to add on 125% of something. So of what? Of, I multiply.
$4.20.
The cost of the wine. Very nice. Now, you can see here that my answer doesn't exactly match all the answers on the left. Now, I have a pretty good guess that my answer is going to be matched with either C or D, because only C and D have that adding. I can see that 420 plus something, but they wrote it in a different form than I did. So one thing that you can do, even if yours is written in a different form than theirs is you can simplify this, your answer, and their guess to see if they come to the same thing. So let's try simplifying ours. 420, I'm typing into my calculator, 4.20 plus, and I know my calculator can do 125%. Don't forget the percent sign or you will get a different answer than you are thinking. Times 420. And I see that the answer, whichever one it is, should come to 945. So let's take a look at these two on the left, Maricela. A savvy student might be able to guess the right one. Does C or D look better to you?
The number C.
You like C. So if we like C, let's not just guess, let's check our guesses. I'm going to go ahead and type that expression in here as well to see if we're right, if the way they talked about it is equivalent to the way I did. So they did 420 plus 420 times 1.25. And that one comes out to 945 as well.
Really? Mine come different.
Then we probably typed it into our calculator wrong. So let's try it one more time. Yeah. So when you typed in C, it came out wrong?
No, the number D. Oh, D. Okay, I see.
Yeah, D came out differently. You're absolutely right. In fact, D was too small, wasn't it?
Yes, it's 4.725.
Yes, the student who wrote D changed their percent into a decimal incorrectly. They did what most students do, which is just put the decimal to the left of the percent, but that's not how it works. Percent literally means divide by 100, so you would have had to move your decimal once, twice, giving you 1.25, not 0.125. But because that's a topic that so many students mix up so much, know how to do it on your TI and you can check your work even if you think you're right. So then the correct answer here is C. So let's look at number 3. You ready?
Yes.
It says Kalani is a server. His company requires that he tip out 10% of his tips each night to the busser and 15% of his tips to the kitchen staff. If Kalani, which I think is illegal, by the way, but I have heard of restaurants that require this. But anyway, if Kalani makes $152 in tips on Thursday night, How much will he bring home after tipping out the busser and the kitchen staff? A lot of information in this problem, a lot of stuff going on, very typical of the GED. Let's start with, where are we going? What are they asking us to look for? Maricela, what do they want us to find?
They want us to take 10% of his tip. Can we put it together and like take like 25 or?
Yeah, we can. So let me get to that. You're not answering my question because you're ahead of me, hon. You're already doing the problem. So let me just go to highlight what we're looking for. They asked us to find, and then we'll get there because you're doing brilliant stuff, okay? It says, how much will he bring home after tipping out the busser and the kitchen staff? So yes, Maricela's right. We're going to have to take out the tips for the busser, take out the tips for the kitchen staff. We're looking for how much Kalani's going to have left after he gives his money away, right? We want to know how much will he have left after the tips. Now, this one's an interesting one because most students tell me, Kate, tips get added on. Yeah, tips get added on when you're paying your waiter. That's not what's going on here. This is a waiter who has to give away part of his tips. He has to tip out. They call that tipping out the kitchen. So this is actually going to get taken away from his money. Okay, great. So we know how much he's starting with, $142. And you're right, Maricela, we're going to have to take out some tips. What's the first amount we have to take out?
10%.
Yeah, 10% of what?
$142.
And we're also going to have to take out another 15%. 15% of what? $142. Now, this is how I wrote it. Now, my students right now get all mad at me. They're like, Kate, I do not like your math. I did not think about it this way. In fact, Maricela thought of it a totally different way. So I'm going to really quick do it Maricela's way because it was brilliant. But let me put this into my calculator right now to see what I'm expecting to get here.
Okay, I'm going to put it too.
I got 106.50 when I typed this entire expression into my calculator.
Yes, I got the same.
Now, Maricela said, Kate, that is not how I thought about it. The first thing I noticed was that I was going to take out 10% and I was going to take out 15%. And Maricela asked me, can't I just add those? Yeah, you sure can. We learned in the very beginning of math class that we can add the same kinds of things. So we might not be able to add dollars and percents, not until we convert them anyway, but we could add percents and percents. Why not? So if he tips 10% out to the bussers and 15% out to the kitchen staff, that's a total of 25% of his tips that he's giving away. So Maricela, is that how you thought of it?
Yes.
Cool. What would you do next if we were doing it your way? Since I recognize this is how the GED usually writes about it, but this is how students usually think about it. So what would you do next?
So I would do 25% minus of $142.
Cool. That will only work if I start with the $142. So let's do that. We'll start with the $142 and then we'll minus out 25%. 25% of what?
Of 142.
Of 142. Let's try it your way and see if it works. 142 minus 25% of means times 142. And you can see
the same answer.
We should get the same answer unless Kate types something wrong. And we do get the same answer. We get 106.50. Good math always works. And I could think of two other ways to go about doing this. So if you're like, Kate, I don't like your way, I thought about it this a different way, that's cool. But we better be able to get to 106.50. Okay.
Oh, I always can do a percentage like when it's like 25, 10, or 90, you know, in my head. But it was just too hard for me to do in my calculator just because I never put times.
Yeah, exactly. And that's why I said the most important thing, like if you walk away with nothing else today, is to realize that saying that word of, 15% of, I'm saying 15% times.
Time.
Even with fractions and decimals, people don't realize that. A half of 10 literally means 1/2 times 10. And students always forget that because they are going, I don't multiply to find a half, Kate, I divide by 2. And I'm like, that's another way, but it literally 1/2 of 10 literally means 1/2 times 10. Whether you work it that way or not, that's what it means. Okay, of means multiply all over the GED. You better know of means multiply, and you better know per means divide. Okay. Can we move on to the next one?
Yes.
I think that my students are actually going to appreciate how you think about things more than how I think about things. So I might start doing these more the student way, where we do one step at a time. And again, it doesn't matter. And again, I might get people mad at me on YouTube or whatever, but the deal is, good math always works. So we're just going to reason our way through these things. So let's take a look at 4. 4 says, a certain medical insurance company requires that patients pay a $35 copay for each office visit, then covers 65% of the remainder of the office visit. If an office visit to an orthopedic surgeon for a new patient consultation costs $275, how much will the insurance company end up covering? Gosh, this is a real life application in percentages. Insurance math, if you go into the medical field, is full of percentages. Okay, so super important math to be able to know how to do, especially if you're the person who wants to know how much they're going to cover and how much you're going to actually have to pay. I know that comes up a lot in my life. So let's give this a try. First, I would like, again, to locate the question. So can you wade your way through all of this information and find what they're asking me to figure out? What do they want me to figure out? It says, the question that they have for me is, how much will the insurance company end up covering?
Okay.
How much? It says how much. Do you think we're talking dollars or percents if I say how much?
Dollars.
Exactly. So I want to know the money the insurance company pays out of the $275. So does that make sense? Before I start planning how to get there, I just want to know where I'm going. Does that make sense?
Yes.
Okay, now I will join you in how do we get there. So what do we know right now? Well, we know the total money that has to get paid, right? The total amount that has to get paid is the $275.
Okay.
Okay?
Mm-hmm.
Look at this wording up here. It says that the insurance company requires that the patients pay a $35 copay for each office visit.
Oh,
Then
okay.
after that, it covers 65% of the remainder of the office visit. So that copay is going to get taken off the office visit price, and then with the remainder, we're going to split that up between the insurance company and the client. Okay, so let's take that copay off first. So right away, you pay that up front, and that bill goes down a little bit. So let's go ahead and do that. How could I, from the $275, take out the copay amount that I paid? It doesn't have to be paid anymore. I've now paid it. I'm going to subtract. So I do that. And now there's $240 left to be paid by the insurance company and the person who's there. So now it says, now the insurance company is going to cover 65% of the remainder of the office visit. They're going to cover 65% after the copay. So they're going to pay 65% of how much?
Of 240?
Of 240. Brilliant. Exactly. And again, I could tell that because of the language up here where they said the copay happens first, then they cover the remainder. Does that make sense?
Yes.
Okay, cool. So let's do 65% of 240. So that means 65% or 0.65 times 240. Again, 2 different ways you could type this into the calculator. You get the same answer. I'll just write it down for you. 65% of 240. Of means multiply. Parentheses mean multiply. Same difference. Or I could type 0.65, which is an equivalent decimal, times 640. They'd both give me the same answer. I don't care which way you go. And I would get
156.
Cool. Insurance company is going to kick in $156. Okay, and what was I looking for? Yeah, I was looking for how much would the insurance company end up covering. So cool, I'm done here. Oh, I love it. I must have been inspired by my daughter on the next question. You ready for number 5?
Yes.
Okay. As an art gallery employee, Kaya makes $13.50 an hour plus a 1.5% commission on any art she sells. Last week, Kaya worked 31.25 hours and sold $3,450 in artwork. What will her gross pay for the week be? So, again, before you tell me how to do it mathematically, just find that question for me. What are they telling me to go look for, to find?
The total of what she make?
Yes. Total she earns in a week, or the total of what she makes in a week. That's what gross pay means. And gross, by the way, gross literally means fat. I know you guys think that like slobby, but it literally means fat or large. So gross is the big amount before they take out anything, okay? So don't worry about taking out taxes or anything else that they take out. Gross is just that big fat paycheck before they take out anything. She earns money a couple different ways if we're going to do the total she earns in a week, right? So we've got this art gallery employee, and we can see her having an hourly wage, and she's got a commission. So if we find the total she earns in her week, we're going to have to figure out her hourly wage, and we're going to have to find out her commission, and we're going to have to total them. In this case, add them together. Does that make sense?
Yes.
Okay, that's my plan. Help me find her hourly wages. How much is Kaya going to make in hourly wages this week? Or how could we figure that out, I should say?
Find what is 1.5% of 31. I mean, we can do 1.5% of 13.50.
Careful. You're mixing up commission with hourly wages. The 1.5% is a commission. Do you see that?
Yes.
And that commission is on any art she sells. So that 1.5% is 1.5% of her art sales. Does that make sense?
Yes, I see.
Cool. So how much is her art sales?
3,450.
Good. And watch how I write that right under the word commission. So I'm doing my planning well. Her commission is 1.5% of the art she sold, $3,450. So I write that under the word commission. Is that cool?
Yes.
I'm not trying to get lost in this word problem with multi-steps. Okay, now let's talk about our hourly wages. Well, how are you paid in hourly wages? You have an hourly rate, and you make that hourly rate every hour you work. So I need to hear her hourly rate and the number of hours she worked. So what's her hourly rate?
13.50.
There you go. And let's think about the way hourly wages work. You get $13.50 the first hour. You get $13.50 the second hour. You get $13.50 the third hour, and so on and so forth. You make $13.50 the number of times that you work hours, or let me say that again. How many ever hours you work is the number of times you will get paid $13.50. Does that make sense?
Yes.
Okay, so we will times that by the number of hours she works, because each one of those hours she's going to get paid $13.50. So how many hours does she work?
31.25.
31.25. And we can see that her hourly wage, see that word hour, is multiplying with her hours over here. And her commission, which we said was on art, is multiplying with the sales of art. See how I can use those units to help guide me? Okay, so let's do that work. I'll do the left-hand side first. Her hourly wage is $13.50 times 31.25. And if you wanted to type the entire expression into your calculator, you sure could. I'm just doing it for the students who usually do it one step at a time. And her 1.5%, don't forget the percent sign or you're not finding what you think you're finding, of 34.50 is only 51.70. Okay, now I'm going to add those two numbers together. And I'm looking at her making 473.625. Okay, but we're still not done with this problem. Even though we've talked it to half to death, we're not done. Can you see what we still need to do? It's rounding. Right now, this is $473, and yet I cannot pay Kaya $473. This is in the tens place, so that's like 6 dimes. There's 2 pennies, but guess what? I don't have a coin small enough to give her parts of cents. you know, I'm already smaller than our coins. So I need to cut off my money at 2 decimal places. We can only go to the hundredths place because our smallest coin is a cent, a hundredth of a dollar. And so 5 is big enough to matter. So I would want to pay Kaya $473.63. And I bet she'd appreciate that because she moved out recently and she's always broke. Okay, it's my daughter. Now we've come to the types of problems that I really expect to see on the GED. They love word problems with pictures. Okay, so let's take a look. Number 6 says, the table below shows the prices of mattresses from wholesale to you. A hotel chain is building a new hotel and will need to purchase 40 full mattresses, 120 queen mattresses, and 40 king mattresses. They decide to go with the Value Plus line of mattresses. If Wholesale to You offers a 20% discount on bulk orders, then charges 2.5 wholesale tax on the discounted price, how much should the hotel chain expect to be billed for the purchase? Dear Lord, this would be GED typical. Tons of steps, tons of information. Where do we even begin? Let's begin with knowing where we're going. What are they looking for me to find?
How much they're gonna pay for everything?
Exactly. How much they're going to pay for everything. Now we're talking about how much they're actually going to get billed. So your bill includes discounts, but it also includes tax. So it's going to be their total after discount and tax.
Okay.
Is that cool?
Yes.
So I got a plan here. I'm going to find the total, but I'm also going to do the discount and do the tax. Do you know what happens first, if discount or tax? Because order does matter here.
Discount?
Yes, they take off the discounts first, and then they tax whatever's left. And I spelled discount wrong, so slip an N in there if you're following me.
I never will find it.
Yeah, I love it. Maricela was like, you spelled fine. It's great.
I understand.
Okay, cool. So let's start. We just said what we would do is we would find the total of all their mattresses. Okay, so we made a little plan here. We said we'd find the total of all our mattresses. Then Maricela pointed out that we would want to take off the discount first. So we subtract discounts. And then once we're done with that, we're going to add on the tax, because tax is an additional fee you pay. How's that plan look to you, Maricela?
Good.
So I think I'll do this like a student, find each one of those pieces by themselves and then put them all together. So let's first find the total for all those mattresses. Oh, what mattresses am I buying here?
Wow. 40 full?
40 fulls?
Mm-hmm.
Uh-huh. What else?
120 queen.
Uh-huh.
And 40 king.
And 40 kings. And if I look down at my chart here, I have more than one price for full. Which one should I use, Maricela?
Oh my gosh, I'm confused there.
It says in the problem. So don't get confused by the chart. Go back and look at the problem. Which kind of mattress did they want? Value plus line of mattresses. So we're going to ignore the other lines. And we're only looking at the value price mattresses. Value plus, sorry. So these are the ones we care about. Okay, so we're going to buy 40 full mattresses, and each one of those 40 mattresses will cost us the same amount. So we're going to multiply by that cost. How much will each of those full mattresses cost us?
$2.99.
Good. And that'll give us the subtotal for the full mattresses. But we're not only buying the full mattresses, we're going to buy 120 queen mattresses. And we're going to have to multiply that by the price of a queen mattress because we're going to pay that price 120 times. So how much does a queen mattress cost us?
$349.
Good. And so the last line of my work here is those 40 king mattresses, and each one of those 40 king mattresses is going to cost me
$399.
Cool. Let's find some subtotals here. So 40 times $2.99 is a lot of money, and 120 times $349 will be even more money. I'm glad I'm not running this hotel. I'd be having a heart attack. And 40 times $399 is 15,960.
Okay, yes.
And there's my individual subtotals for each ones of my types of mattress. How can I find the grand total for all the mattresses?
We added.
We add it. You are doing very well for a very complex problem, my dear. And one thing you should know about your TI is you can actually go steal the numbers from your calculator. So that's what I'm going to do. I'm going to arrow up to the first number that I want. 1, 2. Did I do it yet? 2, 3. And there's the first number I want. It's black right now. I press enter and it'll end up in my calculator. Plus, and I'll arrow up to the next one I want, the 40,000, press enter. And plus, and I'll arrow up to the next one and press enter. And then I didn't have to retype my numbers. Less chance for error. And I press enter and I get a lot of flipping money.
Yes.
Ooh, it's giving me a heart attack. $69,800 is the total price for all the mattresses. Are we okay?
Yes.
Now I have so many students who just stop right here. They feel like they did so much work. They must be done. Hey, we made a plan. We said first we were going to find the total of all the mattresses. We just found it. 69,800. And then we were going to subtract out the discount. We're getting a discount. Hallelujah. We need one on this order. So I'm just going to erase this work over here on the right to give myself some space to figure out the discount amount. What do I know about my discount?
It's 20%.
It's 20%. 20% of what, Maricela?
$57,000.
It's actually going to be 20% of the whole dang thing. The whole dang thing. So the whole dang thing was 69,800. Is that what you were saying?
Yes.
Yes. So I'm going to pay 20% of that whole dang thing. So I'll do that number times 20%. 13,960. Okay, so now we did figure out the discount now. The discount, since it's 20% of 69,800, should be 13,960. So what did we say we would do with our discount? We wrote down our plan so we wouldn't forget, even if we get messed up with our calculators. Our discount was going to get subtracted, minus 13,960. I should have probably used parentheses. It's super duper important, because one thing you need to know is that that tax is not going to be on the original price. That tax is going to be on the discounted price. And so let's go ahead and take out our discount. Let's take our $69,800 and take out that tax of 13,960. Is that cool?
Yes.
Okay. So 69,800, and from that we're going to minus our nice tidy discount. After discount, we are looking at $55,840. Now we can figure out our tax. Hallelujah. So our tax, we said, was how much percent?
2.5%.
Yes. And they even tell you here, in case you're not good at knowing this, it says the 2.5 wholesale tax is on the discounted price. So it's going to be 2.5% of the discounted price, the one we just found, 55,840. Okay, so let's do that. 2.5% of means multiply 55,840, and we find out that they're going to have $1,396 in tax. Now, we already made it in our original plan, but what do you do with tax? What happens with tax?
We add it.
We're going to add it on exactly to our bill. So I'll take that 55,480, whew, add on the $1,396 in tax. And dear goodness, my final bill is $56,876. And I hope you can see why I really needed a plan here, because there was a lot going on in this word problem. And I'm sorry, it's kind of sucky for most students, but that it's that way a lot on the GED. There's a lot of multi-step word problems. So organize, organize, organize. Know your plan before you start. Too many students just start mushing numbers together and pray it works. It was the hardest example I could come up with. So I was looking to get really complex, and I think I win. It's challenging.
We just get lost. It's too much information. I mean, in the question.
Yeah. Yeah. There's lots of numbers you don't need. There's when do you use what? Yeah, there's a lot going on. Let's look at number 7. It says the Yavapai County Swim Team offers family discounts to parents enrolling 2 or more students in their program. You receive 10% off your total registration for enrolling a second child. Plus, for each additional child, you receive and 5% more off your total registration fees. And then we see the question here. It says, how much would a family pay in registration fees who enrolled twin 7-year-olds, an 11-year-old, and a 15-year-old? So we're trying to figure out the total that this family pays in registration fees. Does that make sense?
Yes.
Okay. So first, notice what these percent things tell us. They say that this is 10% off your total registration and 5% off your total registration. So it looks like our first step needs to be to find our total registration fees.
Okay.
Then when we're done with that, then we can take off the discount. Okay, let's go finding our total registration fees. Okay, so we are enrolling some children. The first looks like we want to enroll twin 7-year-olds. Maricela, how much would we pay for twin 7-year-olds in registration fees?
$45 for each one.
Absolutely. So I see registration fees. A 7-year-old would fall in the 5 to 8 range. So we're looking at $45 for each one. I like that Maricela said each one because there are twins. There's 2 of them. Don't miss that word just because it's not a number. So twins, I'm going to pay 45 and 45. Okay, now let's add on our other kids. Okay, so next child I want to enroll is an 11-year-old. How much is that going to cost me?
$55.
Exactly. An 11-year-old falls in the 9 to 12 range, so that will be $55. And now I also want to enroll my 15-year-old. How much is my 15-year-old's registration going to be?
$75.
75. So I'll add 75 into that. Okay. I'm just going to do this work on the side here before I talk about minusing out the discount. So 45 plus 45 plus 55 plus 75 gives me $220 in registration fees, in total registration fees. Okay, so now it's time to figure out my discount. And this is the tricky part here because the language is pretty confusing. So let's go back to where it talked about the discounts. It said that I was going to receive 10% total off. Can I say that again? It says I was going to receive 10% off my total registration for enrolling my second child. Maricela, how many kids did I enroll here?
4.
Yeah, I had 4 kids. Now the first poor kid doesn't get a discount, right? No discount for him. You don't start getting a discount until you enroll the second child. So starting at the second child, I'm going to get a 10% discount. Okay, now it says that I'm going to receive 5% more off my total registration fees for each additional child. So I'm going to get another 5% for this child, my third child, and another 5% for my 4th child. So it looks like I'm going to be saving a total of
20%.
20%. Nice job. So my discount will be 20%. 20% of what?
Okay, here's my question. Do we have to remove the first child from the total?
Good question. Let's go back and look at the wording of the problem. That will tell us the answer. It says that these discounts I was getting was 10% off my total registration. It doesn't say 10% off of the additional 3 children. It says 10% off of my total registration. This one as well said 5% more off of my total registration. So don't worry about subtracting anything out of the 220. That 20% is going to be of the total of the 220. Does that make sense?
Yes.
What a good question. Okay, so 20%, don't forget your percent sign or convert it to a decimal or you will not be doing the math you think you're doing. And 20% of 220 is $44. That's how much we're going to take off. That's our discount. Does that make sense?
Yes.
And now I can do it. I can take my 220 minus off my $44 and hallelujah. I'm only paying $176 to send all my kids to swim. It costs way more than this, by the way. I tried to put my daughter in swim team and I was like, we can't afford it.
Yeah, I tried like 11 years ago with my first one because it was the first one and when she was a baby and I was like, no way.
Exactly. I'm like, you're going to swim in the public pool, sweetheart.
Yeah.
Okay. So we get $176. Whew! Challenging. Very GED typical. Again, it could show up on science, social studies, or the math test, something like this. Thank you for joining me for this week's virtual GED math class. See you next week.